Good day, class. Now let us solve problems on collision theory. This question says that there are three identical steel cylinders that are free to slide horizontally on a fixed horizontal shaft. Cylinder 2 and 3 are at rest and are approached by cylinder 1 at a speed u. We are to express the final speed v of cylinder 3 in terms of u and the coefficient of restitution. Now let's start. Our given. Let u1 be the initial velocity of cylinder 1. Then u2 be the initial velocity of cylinder 2. u3 be the initial velocity of cylinder 3. And we're told that the three masses are equal. That is, the mass of body 1 is equal to mass of body 2 is equal to mass of body 3, which is equal to m. Now, if we take v1 as the final velocity of cylinder 1, then v2 as the final velocity of cylinder 2, then v3 as the final velocity of cylinder 3. Now, let us take a look at the analysis of collision between cylinder 1 and 2. Analysis of collision between cylinder 1 and 2. Now, the first thing we need to do here is we know that our u1 is equal to u and u2 is equal to u3, which is equal to 0 because both of them are at rest. Then the first thing we need to do here, we write the momentum equation. Momentum equation. This one states that what? Total momentum before collision is equal to total momentum after collision. And total momentum before collision is equal to momentum of cylinder 1, which is m1u1, then plus the momentum of cylinder 2, which is m2u2, then is equal to total momentum after collision will be momentum of body of cylinder 1, which is m1v1, plus momentum of cylinder 2, which is m2v2. Then we have m1 is equal to m, u1 is equal to u, plus m2 is equal to m, and u2 is equal to 0, is equal to m1 is equal to m into v1, plus m2 is equal to m v2. Then we have m1 is equal to, m1 is common here, into v1 plus v2. This cancel this, we have u is equal to v1 plus v2. We call this one equation 1. Now we write the restitution equation. Restitution equation. We have v2 minus v1 over u2 minus u1 is equal to minus E. Then we have v2 minus v1 over u2 is 0 minus u1 is u is equal to minus E. When we cross multiply, we have v2 minus v1 is equal to EU. Then we call this one equation 2. Now, when we add equation 1 and 2, adding equation 1 and 2, we are going to have u plus ue is equal to 2v2. Then v2 is equal to u into 1 plus e over 2. Now let us take a look at analysis of collision between cylinder 2 and 3. Analysis of collision between cylinder 2 and 3. Then we know that M3 is equal to M, we are given, and U3 is also equal to 0 because it is at rest. Then also U2 is going to be V2. That one is derived from the first collision. Then we know that V3 is equal to V according to the question. Then we now write the momentum equation. The momentum equation, and this states that the total momentum before collision is equal to the total momentum after collision, and this will be the momentum of body 2, which is m2u2, plus momentum of body 3, which is m3u3, is equal to, after momentum, it will be m2 v2 plus m3 v3. Then we know that m2 is m. Then we have u2 plus m3 is also m. Then our u3 is 0. Then is equal to m v2 plus m v3. Then from here we have m u2 is equal to m into v2 plus v3. Then this cancel this. We have u2 is equal to v3 v2 plus v3. So we have u2 is equal to v2 plus v3. But we know that our u2 is equal to v2. Then we now have v2 is equal to v2 plus v3. And we know that our v3 is equal to v. Then we have v2 is equal to v2 plus v. Then we call this one equation 3. Then let us write our restitution equation. Restitution equation, which says that v3 minus v2 over u3 minus u2 is equal to minus e. When we substitute, v3 is v minus v2 over u3 is 0 minus u2, which is v2, is equal to minus e. When we evaluate, we have v minus v2 is equal to ev2. Then let's call this one equation 4. Then from here, let us adding equation 3 and 4, we have ev2 plus v2 is equal to 2v. Then from here, you have V2 into 1 plus E is equal to 2V. Then we have V is equal to V2 into 1 plus E over 2. Let's call this one equation 5. Then the next thing we do here is we substitute V2, which is equal to U into 1 plus E over 2, that we have already derived from collision between 1 and 2 into equation 5. Into equation 5. So this implies that this equation V, which is equal to V2 into 1 plus E over 2, will becomes V2 is equal to this, which is U into 1 plus E over 2, then into multiply 1 plus E over 2. Therefore, our V is equal to U into 1 plus E squared over 4. Thank you very much. We're expecting question number 2.